1, 2, 3, go!
Hello, welcome everyone. This is our presentation on a use case for migrating from MySQL Galera or Xtradb Cluster to Group Replication using the Kubernetes operator. Will you move the slide?
I will move the slide. Just information. This is a really hands-on thing, and with a lot of commands, a lot of instructions, and you know we know that this is the last presentation of the day, so it's not probably we are not going to be too long, right?
Yeah, we are not serious. We want to be relaxed, so try to enjoy.
Yes, and whatever you guys feel free to interfere and raise questions.
Raise a question. Raise your hand and let the question comes. Okay.
Then this is us.
This is us. Okay, a little introduction for us.
Yeah. First me?
Yes.
Okay, MySQL tech lead, principal architect as well, working DB development for ages to a very long time. And also I'm an open source developer. And now Francisco.
Yeah, my name is Francisco. I'm a senior architect at Percona. I have been working with MySQL for 15 plus years now. I love open source, so I'm an advocate of that. Actually, also I'm a football fan, soccer one, and a microbrewer when I have some time. So I have my side business in the beer, which is, pretty common situation.
We never bring the beer here, so we never taste it. That's the okay. But, but he said it's good. But whatever.
Costs money, man.
Yeah. Okay, so first of all, this is the team that until now had been working on the operator, and I really want to present them to you guys because they are doing a lot of work. They are under a lot of stress constantly. And, I think it's right to celebrate and to, show their faces when we talk about their product. So thank you for what they are doing. Now.
Okay, let's talk about a little bit the why. Because at some point, this is a migration talk from one technology to the other. So what's the actual why? Why we want to move from Galera or Xtradb Cluster to Group Replication. Some things that can be compared between these two technologies. Group Replication created the group communication system based on Paxos, which is a way to get a consensus between all nodes in the cluster when running a transaction. They improved this communication layer between the cluster a little bit over I would call it a little bit over what Galera does internally. It's built at the top of asynchronous replication, so it takes it leverages, let's say, in the binary logs for replaying transactions, for restoring the health of a node, and so on. So it's a very well-known technology. Seems the same is with what we can compare on the way that they cache the information. There is a kind of a memory thing for caching the transactions happening in a cluster. Galera uses a file mapped system using the Galera cache. Group Replication doesn't have that, so it doesn't require to write to this, which reduces the overhead when running these transactions. It is built at the top of CTID, which is a technology or a feature that has been around since 5.6, so it's been for a long time. Galera relies on a sequence number, which is internal to the Galera plugin. The flow control, which is the mechanism to slow down the cluster when a node can keep up with the replication. Remember, this is synchronous replication, so all the nodes should have the same data at all times. There are some exceptions. But the flow control in Group Replication never locks the cluster as Galera does. So it slows down the cluster, but you can keep writing at a certain rate. Both support some one replication. Yeah. Yes. So the question is, if the reducing the throughput of the flow control in group replication reduce the throughput. Yes. The flow control in Galera lock the cluster. So when you have flow control, the cluster freeze until the offender node gets up to date. Okay, so there's a big difference here because you don't have downtime.
Yeah, and it's much more affecting, right? So it's also the other thing is that is also calculated in a different way. While in Galera you really have a number that is the queue, that if you exceed the queue, you start to take action. In group replication, it has a calculation based on several metrics. Based on that, it sees the performance for each node, and based on that, decide, okay, I need to slow down that %, and I need to recover that %. So it is definitely more intelligent.
Yeah, and more flexible as well.
And flexible and less impact.
Yeah, and the certification process works in a different way. When Galera creates a certification based on the, a knowledge of all nodes, if you have 3 nodes, you have 3 messages. Group replication requires just the majority of the nodes. So if you have 7 nodes, it's enough to have 4 knowledge that will be good. That's different from the certification because there you are mixing 2 different things. Certification is, can I run this transaction like I don't have a duplicate key, for example? Okay, that's certification. 2 out of 3 nodes is enough to certify the transaction. The other thing is flow control when one of the nodes, for whatever reason, is slowing down the cluster. This is synchronous, so all the cluster will have the same data. If one node, let's say, I don't know, the disk starts behaving weirdly, so it's slowing down every commit. That's flow control because, the cluster this node cannot keep up with the cluster. Okay, these are the 2 different things. And is it clear? Okay, thanks. So, one support, you love it, right?
No.
No, never, ever try to put a cluster geographically separated. No. The one support is there. It can be done. It sucks because there are physics behind this. So if you separate a cluster long enough, the latency in every write will be so high that you will not be able to write transactions in a decent way.
No, latency will kill you.
Schema changes. Well, this is an interesting topic. Galera has 2 methods to deploy the schema changes. One is the default, which is totally isolated order. Basically, totally order isolated. Toy, yeah. Okay. Basically, is if you run a DDL, the cluster will run the DDL, will lock every other operation until it's done. That's the default. The other one is rolling schema grade. You have to run the DDL on each of the nodes manually. So if you run here, then you have to run here, and then you have to run here. But in between, the cluster is not consistent, so you can fall into problems. Group replication created this method for schema grades that is the default, right? Eventually consistent.
With eventual is default.
So what does it mean? It's eventually consistent. You run a DDL, and the replication will take care of the rest. You will eventually have a node or the cluster get into the same state. So once the DDL finish in the first node, it will be replicated to the whole cluster, and the main node or the primary node will accept every type of operations. And then the other nodes of the cluster will eventually get in sync with the primary.
The important thing is that the secondary node will apply the change in parallel, not on rotation. So
there won't be any lag type of things here in the group application, right? Normally, if you're running a DDL, right?
There is lag because it's eventually consistent. So you need to wait for some time to the rest of the nodes to be in the same state at the moment that the primary. Well, that is single-threaded replication. When you have multiple threads, you can apply some transactions in parallel in the slave. But you will have some delay. The concept of delay, like you have in the asynchronous replication, is not applicable here. Because worst case scenario, you have a flow control, so everything is slow. But you don't have, you have milliseconds between one instance and the others. It's not like hours or so.
So it's not going to block other transactions, right?
Yeah.
If it's a line operation.
Yeah.
if it's online operation.
Yes.
If it's not online operation, you will impact anyhow.
Fair point. If you want to change a primary key, you have a metadata locking. So that will block the cluster, yeah.
Right.
And finally, the OS support. Galera works on Linux distributions only, while Group Replication has binaries for Linux and Windows. Because Oracle creates these binaries for Windows too.
Oh, yeah.
Linux. Whatever Linux flavor, yeah.
Whatever
You
Linux,
have Red
that's
Hat,
fine.
you have, well, the official XtraDB cluster is only, it has released for Red Hat and Ubuntu or Debian. But Galera as a plugin works actually in MariaDB as well with other.
Yeah, but it's still.
No. But yeah, it's Linux flavor. CentOS? Yeah, because it's Red Hat compatible. Yeah,
it's compatible.
CentOS and Rocky now, they are, and Oracle as well. Yeah, Oracle Linux as well. Yeah,
all the
they
Linux,
are Red Hat
all the
compatible. Yeah,
Nix thing.
it's RPMs at the end.
Okay, and why it's not working? Okay, and this is why one of the final part of the why is Percona Xtradb Cluster is the Percona Xtradb Cluster, and for us Galera is one technology, and now we are introducing a second technology for the cluster implementation. So group replication is part of the Percona Xtradb Cluster umbrella. And why migrating this is because given that we want to give the user the possibility to see how to migrate from one to the other if needed, right? As needed.
Yeah, a little disclosure. It's not like we are in favor of one of the other solution. At least not me.
No,
Not now.
No, it's well. I love the Galera guys, the Codeship friends,
Yeah.
but at this point, it's
Eventually, group replication will be the de facto solution
Yeah.
for these types.
because it's integrated.
Yeah.
It will become the de facto solution. So just a very quick overview. I don't understand why. Okay, doesn't matter. Overview of how the operator for MySQL looks like. It is a service, a complete service, and then you have the load balancer. Then you have one pod that is this is a pod. You have the load balancer on top. Then you have a container with the proxy and the monitor that checks the activity. Then you have another container where the data nodes are running. And this is the layout of the proxy of the Percona operator for MySQL with PXE. With group replication, if you see, is exactly the same thing, right? It's exactly the same thing with the only difference that for proxy, at the moment, we are using MySQL router. Consider that the solution for group replication is still in technical preview, so is not production ready yet, right? And the important thing here is that we are using MySQL router, and during the test that we have done, we also have evidence that the MySQL router is not the right tool to be used here. We adopt it because it's part of the MySQL cluster solution. So we try to be as much as possible compatible with upstream with the solution that they provide. But in this case, we actually see that the router is not a good way to go, and we will replace the router. We are actually working, the developer team guys are actually working to replace the router with HAProxy because it is the one that consumes less resources and provide better scalability. And okay. Okay, this is the classical standard way of deploying a Percona operator service. Yeah, sorry, thank you. I'm starting to not sleeping and presenting is a horrible combination. So this is a classical layout where you have a production site with a disaster recovery site and a synchronous replication in the middle. Sorry. These slides show HAProxy, yes, because HAProxy again will be the final proxy present also for group replication, and this is the layout for anyhow for the
this is the operator for PXE.
With PXE technology that has HR proxy in it already. Yes.
So now, what I'm wondering now, since you are also calling this PXE, right? So you just said that. So does PXE now just mean, or soon will it just mean two things?
This is the idea. This is the idea. Well, because the point is PXE, Percona Xtradb Cluster. Xtradb is the engine, right? The storage engine. Is not the Galera, which is the replication layer. Yeah. So the Percona Xtradb Cluster means a cluster based on Percona Xtradb storage engine, which is the same. What we are going to do is to support two technologies. One is Galera, and the other one is group replication, which is embedded, and inherited by upstream from the Oracle, It just happened to be. So what we are going to build in the exercise is actually this. We will have the operator deployment for PXE technology here, and the Galera group replication here. And what we will do mainly is to create one node first, and then take the data out from the source, that is the PXE, and then build asynchronous replication between the cluster in order to keep the generated solution up to date with the data until we do the shift. Yeah.
XRDB and InnoDB, they are the same or they're little different? Because you are saying like Galera.
Okay, yeah.
You go for it.
Okay, so the question is about the names that we have been using to name the technology, the server, and the solution for replication. So let me put some clarity here. XtraDB is Percona server. Is the engine which is pretty much InnoDB on steroids, because we grab the upstream version from MySQL, from Oracle, and we patch InnoDB and some other components to create Percona Xtradb, which is Percona server. The Xtradb cluster solution is built at the top of Percona Xtradb server plus Galera plugin, which is the synchronous replication solution. In the other hand, we have Group Replication, which is, we are adopting that name actually, right? Yeah, we are not changing that.
We are not changing for the PS.
InnoDB cluster solution is Group Replication plus the shell plus MySQL router. That's the InnoDB cluster. It's 3 components. But the main component that we will be using, actually we will use MySQL router, but the main component is the database, which is MySQL 8.0 in this case, plus the embedded plugin, the Group Replication plugin. Now it is embedded on the binaries. In the previous version, like 5.7, you have to run something, install plugin, Group Replication. It wasn't a big deal, but it wasn't installed by default. Now it's part of the distribution.
Okay. But this is good because it shows that we have to work on the name definition because it's not clear. Okay.
MySQL, I come from a different database world, and it's pretty confusing, cluster.
Absolutely yes.
Yes.
Totally. Absolutely yes.
They tried to make that fair point about the InnoDB cluster because there is a trick. MySQL as a database has a technology called it's an API then you can plug any engine. It's pluggable engine. So every engine, storage engine in MySQL is actually a sort of plugin. Okay, so you can run MyISAM if you want. You can run some other, but those are not compatible with Group Replication. So Group Replication, to become a product with other components, is the InnoDB cluster. It only works with InnoDB, and you are forced to use InnoDB with some conditions. It's not anything on InnoDB. You have to set up primary keys. There are some things that you cannot not having to make it work.
So that means there is no, what is that other thing called
Federated.
Federated?
Yeah. No.
Right?
No.
Only performance schema, information
Performance schema and MySQL, information schema, sys schema, they are databases, system databases that are, yeah.
InnoDB.
Now they are InnoDB. No, performance schema is its own engine.
Yeah, well,
Yeah, it has its own engine. But now, from 8.0, MySQL system database is InnoDB. Before, it used to be MyISAM. Yeah. Yeah.
So group replication is only supported on InnoDB.
Group replication is only supported by InnoDB. Yeah.
Not on XTradb now.
XTradb, yes. Well, Percona server, yes.
yeah, because you inherit it, right? Inherit it together with the server.
You think on XTradb only? No, XTradb cluster. XTradb only as Percona server.
But
Okay.
well, the point is that also in the Percona Xtradb, I mean the Xtradb cluster for
You
PC,
have the plugin
you
available.
also have the plugin for group replication.
Yeah.
This is the confusing part.
InnoDB is a number of things. Put it in a simple word. InnoDB is a Oracle MySQL product. The XTradb is an equivalent product, right?
Yeah.
Somehow, yeah. We actually follow upstream, so whatever.
The binaries are the same. Is how you compile with different components.
And actually, it's so the same that it's a completely drop-in replacement. So if you are running a database in MySQL, you can just shut it down, replace the binaries with Percona, and start, and it will work. And you can do the opposite.
Okay.
Stop Percona, put MySQL binaries, and it will work.
Need to go ahead. Otherwise, yeah. Okay, so the steps that we will show more or less is download download and review the KA definition for the operator, roll out a standard group replication Kubernetes solution, collect some failback information. This is a safe step, as you can skip if you want. Then prepare for work with replica nodes, then do the clone or the backup of the data, build asynchronous replication, rebuild the group replication cluster, and add the missing node and start the asynchronous replication. Now, those are first of all, if to install the operator, just read the information and download all the code from GitHub, right? Once you download the code, there is a file called crm.yaml that is contain the information. In this file, what you need to do is to expose, first of all, the pods from source, so from PXE, and from replica, so from group replication. So what we are doing here is we are referring to an existing instance of PXE on Kubernetes, right? So that instance already exists. The group replication is new because we are moving data from an existing situation to something new. And what you have to do is to expose the node, because in order to work with a clone, we don't want to go through the load balancer. We want to point directly the specific MySQL node and be sure that the data is taken from there without any problem. And so what you do is just say in the expose instruction, expose enable true and the type load balancer. This is in the cr.yam. And of course, set the sites for the group replication file, the CR.yam file, set the sites to 1, so we will start with only one pod for the group replication, while the PXE already has all the layout, complete layout. Again, for the group replication specific variable and definition, you can use the MySQL operator calculator that I wrote. It is on GitHub. That it help you to provide the whole set of information and settings in one shot without getting mad, about calculating that by yourself. Then and the example is here, what you will get is something that lose belong transaction dependency, a lot of information, a lot of different variables that you can add there. Now, I have my cr.yam file. What I have to do is to use kubernetes.ctl to create the environment. So I created the namespace, and then I choose that as a default namespace. then I start to apply the different files in order to build the environment. And it's very simple because you just do Kubernetes apply server-side bundle, which will create all the resources connect that our service will use. Then the secrets that contain all the passwords that will be encrypted, and everything is there. And then finally, you apply the crm.yam file with all the instructions that I said, about the different variable and so on. And then you can do a Kubernetes get pods. To delete is very simple. You use Kubernetes control delete file and then delete the PVC. PVC are the volumes, right? The volume, the disk, mainly. So if you do not delete them, you will have at the end of the exercise, you will have the disk, wasted there.
Some storage allocated, yeah.
Yeah, storage allocated. Sorry. So when you do Kubernetes get PO, you get the situation. So you will see what is happening, right? And with Kubernetes get service, you will see what is actually the service accessibility, right? The entry points. And you can see that normally, where is it? Let's go to router. Normally, you only have the router, right? The load balancer for the router. But because we give expose, we also have the MySQL node expose, this one, that normally is never exposed to the public for security reason. So this is also very important, okay?
And also a single instance. It's important to clarify. You have only one because the size of the cluster is one. You don't have three
there is
MySQL.
only one, because the size of the cluster is one, and in order to achieve to do that, in the CR-YAM file, you also have to say unsafe configuration true. And this is because as I said, normally you never ever expose the node directly to the public. And if you do get pods instead for PXE, you have the full. You can see that the full cluster has been deployed with 3 pods for the HAProxy and 3 for for PXE, and the load balancer for HAProxy is here. You have the 2. One is for read and write, and one is only for reads. But also in this case, we have exposed all the nodes in order to grab the data, and that is, those are the addresses. Now, what we have to do is, I reiterate that, is a security issue. So keep the node exposed only for the time of the migration, because it's very, very, very dangerous, okay? I don't know if there is another way to do it, to expose Chetan. You are the Kubernetes expert, but anyway, Chetan is the Percona Kubernetes expert. If you have any specific question about Kubernetes, he's here for you to answer after. But there is any way that you can think about reaching directly without doing port forwarding, reaching the node without expose?
For the pods?
Yeah, from one cluster to another cluster.
No, it has to connect over it.
Okay.
Otherwise, the application is not.
Okay.
How can you deploy the same Kubernetes cluster but in different namespaces?
No.
It's different operators. One is for creating
No, you cannot do it. 2 different things. You cannot combine in the same.
You have a Kubernetes stack, right, cluster, and within that you have a dedicated namespace that is running your Galera.
Mhm.
And you create a separate namespace and you deploy the PXE of it.
You are talking about the same nodes, right? The same VPC, the same thing.
Yes.
That is actually my case. But they build up a virtual network that is completely incompatible. So you cannot connect from one to another unless you map the.
By
the
default,
address.
the whole installation is secure, so it's like everything is
Completely
encapsulated, and there is only one entry point, which is the load balancer.
So basically, the pod should handle like everything connectivity. As long as that's happening, it's fine. So if you're having it in a different cluster, right, the only way it's possible is you need to expose it. Otherwise, the L3 communication is not happening. Or the other alternative is, you can use something like a submariner, which kind of exports the services, like exports the services and exports the service in another cluster.
Okay, let me go ahead. So user migration, this is also another thing that is very important. Don't use or existing user for that, right? Just use a different user specific for this operation, and the grants that you have to create the user, of course. Grant backup admin on source, so the user will, from the replica, from the group replication, which is the replica for us, will be able to connect and act as a backup admin. And instead of replica, you have to grant more in order to be able to do all the different operations. So grant system user, replication slave, connection admin, backup admin, group replication stream, and so on. Now, of course, this is up to you, because with the steps that we are providing, it's not really needed, but I like to be safe and to be and to have any kind of fallback information if I need it. So it is possible. We recommend to take information and copy somewhere about the user and grant, the MySQL cluster metadata, and group replication variable. So here, this information are coming from the information. This is the schema that will be created when we create the group replication. And this is a MySQL InnoDB cluster metadata has inside several tables like clusters, routers information, and so on. If you do a simple MySQL dump of the user table and the schema for MySQL InnoDB cluster metadata, that will be more than enough. Now, prepare to work with our environment to work. In order, as I was mentioning in my previous presentation, some of you were there, we have, the operator is a mechanism that constantly check the different pods and the different MySQL service, how they are doing. And in order to have this relax while we are operating, because we will do operations that eventually will conflict with health, the good health of the service, you need to, first of all, modify the probe timeout to set to a ridiculous number, so as high as crazy. And then we have special file that can be used that can be created in the directory where the data for MySQL is stored for the replica nodes, and that will prevent, that file mainly means for the operator, hey, don't worry about it. Just stay away from me. And the action to create this is this Kubernetes control that is specify, connect to this pod and connect and and create the file. And in order to remove, you provide a command to remove. Once you have done, you need to choose if you want to clone or do a backup and restore. This is another very important thing. The Percona server operator is can use whatever kind of compatible Percona binary exists. Actually, it should also work with MySQL binary, right? I didn't test it, but it should work with MySQL binary, because all the configuration, all the changes that needs to be done are done once the instance is running. So it is important, because if you're, for instance, if your cluster already in production is 8.0.28, and you have, and the last version of MySQL of Percona is 8.0.32 or 33, you don't have to go for the last one. You can use exactly the version that you have in production, do all the migration, and then let the operator do the upgrade, the versioning upgrade, when everything is done. So it's an automation that you can utilize at the end. You are looking at me strange. Is okay or okay? So the other point is, if I really cannot do that, I can do a backup and restore. But the backup and restore is way slower than the clone operation. I mean, clone operation is like 5 times, 6 times faster than a backup and restore. So it's much more efficient. And it's fully automated. So you don't really have to do any manual, well, just one command at the end. So let's say that, first of all, we go for clone, right? So what we do is to create the file. So the operator will stay away. It will not touch. Then what we will do is to connect to our Galera node that we have created. We want to be inside the Galera node to operate. And from there, we will do MySQL, user, password, and we will connect locally to our group replication instance. And we will, well, in this case, we have one node, so this command is not really needed. But there is a way to do with multiple nodes, but I suggest you to work with one node at the beginning. And then you do a select from performance schema, replication master member, and you can see that everything is online and primary, so our node is ready to go. And once we are there, we go with a Kubernetes CTL, we go and query the service for the PXE. We copy the address of the node we want to connect to, and we set as a valid clone donor, just set that, then stop group replication, set global super read-only to 0, because when you stop group replication, automatically the node enable the read-only. So we need to disable clone instance, and that's it. At that point, the clone operation will start. It may take 5 minutes, few hours, depend how big is it, how big is the database that you are cloning for, and mainly this is it, right? Once you have done that, it's the game is over. Well, if you instead do the work using the backup, you have to connect internally, and you need to check a lot of information. And sorry, do clone backup, close.
Yeah, you're restarting MySQL now.
Yeah, no, this is the other one. Yeah, for backup. I really prefer to do not show that because it's really complicated. A lot of things can go wrong, and I don't suggest you to do it. Sorry about that. I should have deleted that slide. So instead, we have everything up. Everything is done. Everything is now cloned, and we have our service. During the clone operation, our MySQL D instance will be shut down, okay, will be stopped. And this is a problem because in the operator, in order to do not have the auto restart, but there is no MySQL D safe daemon, so the automatic restart doesn't happen. So we need to manually restart it. So what we do is to connect to the node and as before, start MySQL D. And then the first action that we have to do is to just recreate these users. These users are the one used by group replication, and the password is the one that you have in the secret file. So you know them, right? It's very easy. You just have to regenerate the users that had gone lost because the clone overrode that. Yeah. Now, once we have all this, the next step is to build the asynchronous replica. And you have to do that before recreating the group replication, because otherwise you will have some conflict with the shell commands, okay? So what you do is select the executed GTID, just to confirm that you get the data from the PXE, and compare this with the information that the select executed GTID is from source. Then take the information, compare with what you have on the group replication, and if match fine, it should match, but if it doesn't, you can simply take the executed GTID and set the global GTID push as the GTID that you get on the PXE. Keep in mind that at this moment, you have exactly the same amount of data that you have on PXE plus the new users. At this point, the only thing you have to do is create the, define the replica channel with change replication source mask, replication source to whatever, and check if it works. Starting the replication for the channel, you will see that everything is working fine. The server can catch up. At this point, stop it. Otherwise, you will have problem in creating the group replication.
Yeah, let me clarify a couple of things from this command, which are very important. Number one, involve source connection auto failover. We're going to configure this later within the group replication cluster because we want that asynchronous replication remains running even if my actual node acting as a replica goes down. And the second part is that we need to name a channel. This is pretty much mandatory in 8.0 now. But you need to name the channel because group replication will have its own replication channel. So you need to somehow separate them.
Yeah. And once you have done that, other three simple commands. For the time that we are doing the migration, what we are going to do is to create this 3 entry, each one pointing to the PXE cluster on each node, okay? Because if one of the pod crash, we want the replication to continue to exist, right? We want to continue to read from the source to the replica. So if one pod crash, if you provide this, the group replication cluster will be able to continue to read from another node, PXE node. And at this point, the synchronous replication is set. We go ahead and rebuild the group replication cluster with a MySQL shell from the operator node. We connect to the operator node. And from the operator node, what we do is just connect to the MySQL shell and issue this simple command, db create cluster and PMS, the name of the cluster. And the only thing we add is the force instruction in order to bypass any problem that the shell will eventually identify because we already have a synchronous replication. Say that, our cluster is up, and we can check it. It will come up as okay, no tolerance because there is no additional node, but everything else will be online. We are ready to go. What we have to, we will see it. The replica is up. The router is happy. This is a step I missed. Once you have rebuild the group replication, the only thing you have to do is to delete the proxy, the router, or the HA proxy, because they need to re-register. And given the fact that they are stateless, let's say, it will automatically done without any problem. So you delete them, it will instantaneously rebuild, and you will have the cluster working right away. At this point, the only thing you do is changing the sites from 1 to 3, and automatically the operator will repopulate the cluster, and you will have your 3 nodes for MySQL in group replication, 3 nodes for the proxy, in this case router, and then everything is ready for the last step, which is activate the asynchronous replication, which is, as he was saying, change replication to connection the failover to 1, and then start the slave for the channel. The the channel will say that are connected, they are replicating, and everybody is happy and working.
Go back. And now you can see how the old school work. He's still using start slave, show slave status. This will no longer be used. You are old, man.
I am old.
Okay.
Yes, I'm
Go
old.
ahead now.
I'm old. I cannot understand this thing of changing
So
the names.
now
It's the same
show
thing.
replica status.
Yes. Okay. And now not in testing, not in production, but in your environment. But everything is up and you can do it. A few notes. I know that it looks a lot cumbersome, but it's not. To do all the process takes less than 15, 20 minutes, literally, to do the whole thing. And in fact, what we are trying to do now is to have that led by completely automated. So, but this is not yet, but you can try by yourself. You will see it's taking nothing to do it. And the operator for Percona server in group replication, as I said, is technical preview. For the moment, PXE is still the primary technology. And as I mentioned already, the router will be changed. And conclude, okay, this is, we think that this is one of the cases where the operator can, the automation around Kubernetes and the operator is one of the cases that help you a lot because you can do a migration also on Iron, whatever. But it is really simple here. It is really simple, and once some step like the creation of the cluster after you have done the clone is automated, the steps are minimal. Really, it's just a couple of things like creating the file but that also will be automated. It's one of the situations where it makes a lot of sense to use the operator. There is, as Francisco was saying, no fight against PXE or whatever. It's just what is better for you. And migration is always a risky business, so back up your data before doing whatever. Okay, that's it. Thank you. Any questions?
Any questions?
No. There is a lot of things.
It's a lot, but it's simple.
Yeah, it looks more than what it is. It takes nothing. If you take the slide and you do it on GKE or EKS, it takes literally
Minutes,
15, 20 minutes.
Depending on the data set mostly, the size of your
It's the time
source.
of the clone. It's really the time of the clone. Okay.
So, yeah, of course.
Yeah. Well, this is a common topic. I mean, a lot of people are interested in what can be done, what is possible to do, and the flexibility that it brings, but they have not touched it yet, right? So.
We are trying to understand step B before step A.
Yeah.
So we have to reverse engineering.
So when do you guys think the group replication is going to be GA?
Group replication has been GA for a long time.
No. The solution.
The operator, you mean?
The operator,
oh, okay.
No. The operator.
The Percona operator.
I don't have with me the product manager. I can ask if you want. I can ask, but it takes some time because to be honest, it will not be soon because of the problem with the router. Okay, we were ready to go, and then we had to slow down slow down everything and stop because we saw that the router is not working as it should at all, and we had to modify the architecture.
It's going to be replaced with the HA proxy.
Yes.
And the HA proxy is very easy to use.
Yes.
Hopefully, Q1 of 2023.
Hopefully before the end of the year. Hopefully.
Did you say stay away before that HA proxy?
Pardon me?
Did you say just wait on that to be finished before testing this HA proxy?
Well, we need to test, we need to wait for the HAProxy implementation, testing and everything. But if you want to test it, that's for GA. If you want to test the functionalities, you can test, actually no, test now, because if you identify something that is missing, something that you want, now is the time for us to know it, because it will cost, in terms of time, us less to put our hands on now that we are not GA already, right? So it will be faster to implement.
Yeah, and technically, it wouldn't make any difference in the practical terms. It means that if you try now, you still have the same functionality. It's just the router doesn't scale well, but when it will be replaced, you still have two interfaces for the load balancing. It's pretty much the same, so it's pretty transparent, they change.
Yeah. At the end, for the user is only benefit. They will not. Yeah.
Will remain the same.
Yeah. It will be
any change on the application side.
because the router as well has different entry points. Read, write, and only read. So it's exactly the same thing.
So the group replication with HAProxy operator is available for customers to test?
No, the group with router. With router is out for test. Yes.
The reason why I'm asking is if I am embarking on Kubernetes, right, I would rather want to go directly to test it with HAProxy rather than testing something.
Okay, yeah, you're right. In technical review, technically, the only difference will be what component is doing the load balancing. But from an application perspective and database perspective, there won't be any change. So eventually, when the operator becomes EA, there won't be any infrastructure change because you will be pointing to the same IPs and everything. It's just like, as changing the layer that is doing the load balancing.
Yeah.
Yeah.
This is also why we are, the technology behind the service is, we are trying to, this is something that it is a little bit different from standard approach, right? At the end, what you have is the service, What is behind is hidden by the service itself. And what we are doing is trying to combine all the best component all the time, that fits well and do the best. But at the service level, it will not change because what you see is the entry point. So, so.
The only change variable is HAProxy.
HAProxy against router. And as I said, we choose router at the beginning because we said, okay, if the standard configuration from Oracle for the cluster, for InnoDB cluster is with router, let's go for it. No, absolutely not. Yeah, I have to return the microphone.